In this video we're going to show you how to set the X, Y, and Z locations for your work coordinate system in the hybrid system. So first we're going to pull up the MDI menu. So this is we just went to MDI program. And this will pop up our program window. We're going to type in a known tool, a tool with a known length. So let's go M06, that's the code to change the tool, and we're going to go to tool 4. Now you have to press end of block insert. Now your code's in MDI. When you press cycle start, this green button, and the machine will then move to change your tool. I have single block on right now because when the machine first starts up it's in single block, so I'm going to press single block to turn it off. Press the green button, and now the machine will move and change to our tool 4. This tool is our edge finder. I just also have measured the length on this previously, so I know how long the tool is. Once our tool's in here, we want to tell the machine that we know how long the tool is. We've already measured this, so this is in our G43 height table. So we're going to go G43 H4. 4 matches the number of the tool that we just called up. Tool 4. Once that's in there, we will do end of block insert, and then we will call it. The machine won't move, but if we go to position, we will notice that our Z height should have changed. Once we have our tool height compensated in the machine, we will go ahead and open the door and move the table to where we can measure the Z height. So first, I'm going to switch this from auto to manual mode. This allows me to use the handle with the door open. I'll go to handle mode. That allows me to use the jog pendant. So then I will also open the door. I press the door open button, open the door, and now I will use the handle to jog the part under the tool. If you're concerned about the rotation of the table in either direction, you can also use axes 4 and 5 to adjust the tram. So 4 controls your C axis, 5 controls your A axis. So you can indicate in if you're worried about the tram of those axes. Typically we don't worry about it though. Typically it's usually fine once it's set to 0. So once we're ready to measure the height in the machine, we'll go over to our tool drawer, and I like to keep a 5/8 inch dowel pin in here. This is just a ground surface with a known dimension. It's a hardened steel, so it's always 5/8 of an inch in diameter. Now we'll take our dowel pin and we will measure the Z height. So you want to try rolling the dowel pin under your tool. In our case, it's not going under, so I'm going to raise it up using the jog pendant. And then I'm going to go to the smallest increment on the jog pendant, the ×1, and just move up slowly until just when this dowel pin passes under. I'm going to go back down, just verify that just passes under. So once you find that point, go ahead and turn the jog pendant to off, and now we will set our height in the software. We're back outside the machine, and we're going to go to the offset settings menu. So this is our tool table, our tool offsets. We're going to go to work because we're setting our work offsets. We want to go to our G54 numbers, which are over here. We currently set our Z. The way I like to do this is you just tell the machine where your Z height is, So we just found our G0 location, but we also added that length of the dowel pin, that 5/8 inch. So we tell the machine that 5/8 is 15.88 millimeters. So we're going to go Z 15.88 millimeters and then measure. You'll notice that our Z height changed to 15.88. That means that the current location where we just had the pin just slide under the tool is now assigned as our 15.88 location. Remember that you have to have the tool height measured in here, otherwise the machine won't compensate your tool height and it'll try running the spindle at the location where the bottom of the tool is right now, which would be bad. It's also a good check to note this number. It should be around -350 for most of the things that we do. If it's less than that, if it's like -250 or -200, even -300, just double check that your tool length is compensated in here. This is a pretty easy place to crash the machine and have a really bad day. So now that we've found the Z home position, we're going to find X and Y. So I just shut the doors to the machine. I'm going to switch back to automatic mode. We have to be in auto to run any of the auto, edit, or MDI modes. So we're going to go to MDI and program. We don't have a probe and we don't have a Heimer, so we are just going to go ahead and use our edge finder here. It's typically in tool 4, but that may change in the future. We're going to start the spindle around our typical edge finder speeds. So in this case, it's M03 S1000. S1000, we're going to go ahead and press cycle start. That starts our spindle spinning clockwise. Now we'll go down here to handle and use our jog pendant to find the X and Y. So I just moved the machine over with our jog pendant. I'm going to jog the machine down and just use the jog pendant to find our XY location. So let's say I want to find the bottom left corner, the front left corner. I'm going to move very slightly until I see the edge finder step over. If you're not familiar with edge finders, I suggest you go next door into the machine shop and play around with them a little bit. They're fairly easy to use. It is more difficult in this machine because we can't see the edge finder step off to the side in the x-axis, but it's definitely feasible. So I've just found the x-axis where it steps off to the side. It's difficult to see, but you can see there's a little bit of a step there. I am going to first shut the movement off on my, well, before I do that, I want to move up in Z so it's not rubbing on our tool. So I'm going to move it up in Z just so that our edge finder isn't rubbing on our part. Now I'm going to shut this motion off on the pendant so I don't screw up my dimensions. I'll go to offset. I know the width, I know the diameter of that edge finder is 0.2 inches, so the radius is 0.1 inches. If we convert that to millimeters, it's 2.4 millimeters. So I will go into this menu, I will type X negative 2.54. That says that the edge that we currently measured, or the position of our tool, is currently negative 2.54 millimeters from the left side of our part. I'm going to say measure, and our number should change here. For the left side of the vise, it's usually around negative 51, and we'll do the same in Y. Now to double check, we will go and stop the spindle first. So you can either press reset or type in M05. That stops our spindle. And then with the tool above the workpiece, we're going to go G43, G43H4, because that's a tool we're in. We're going to go to G90, G54, end of block insert. So that sets absolute mode with our G54 work coordinate system. Now we're going to go in rapid mode, G00 to position X0, Y0, end of block insert. So if I go to our program check menu, when I press cycle start, we can see we've got -13 to travel in X and 2.4 to travel in Y. So when I raise the feed rate knob down here, it slowly moves to that position. If you're in the low speed, if you're at 25% rapid, it will scare you and be really fast. So usually just keep it in low unless you know what you're doing. And then we will just open the door and check to make sure our axes are aligned. X looks okay. Y also looks okay. So we're just double checking that it's okay, and it looks to be alright. So that's how you get your work coordinate system set up in the 5-axis Hardinge machine. Changing a tool in the hybrid is really easy. First we're going to go to Program. We want to be in this screen. We will type in M06 and then go to whatever pocket that you want to be in. So I'm going to go to T8, end of block insert, and then you press cycle start. The machine will move to grab that tool, put it into our tool holder. That's pretty much it. If you want to take this tool out of the spindle, first we want to be in one of the manual modes. So I'm going to go to handle. It can still be in auto mode, you just have to be in one of the manual modes. And then we will use the tool off button, or take the tool button in the machine to take the tool out. So this is a two-handed operation, so I'm going to set my phone down. We go over to the left here. You should be able to see that's our tool change button. It's behind this manifold, very well hidden. So we'll press that while you're holding onto the tool, and the tool, the pull stud, the drawbar will let go when you press that button. You want to make sure you have a hand on the tool, and then you'll be able to take the tool out. To put a tool back in, you just do the reverse. You get your tool in one hand, have another hand on the drawbar button. You press the button, put the tool up. The orientation of the tool doesn't matter because it's a BT40 spindle. So you just have to make sure these those little bosses are aligned with the cutouts on your tool. And then once the tool is seated properly, let go of the button, and then it'll be secure in the tool changer, or in the spindle. So once you do that, it's crucial immediately after that to measure the tool height, and that'll be shown in another video. So for this program, I have to do a little bit of drilling. So I've got my fancy 100 thou drill. It's a cobalt drill that we need to put inside the machine. So we need to change our collet and tool holder to accommodate this tool. The specific collet holder that I pulled out of the machine in the tool changing video is an ER25 holder, so I'm going to go over to my ER25 collets. We also have ER32s and a couple ER16s, but I just want to find the collet that most closely matches the diameter of this tool. You can also check on the face of these collets. They tell you in millimeters usually what diameter they're meant for. So this one goes from 3 to 2. This is 100 thou, which is less than 3 millimeters and more than 2 millimeters, so this collet will work for this tool. I moved over to the side of the Akuma. This is our tool mounted on our tool holder. I need to remove the collet from this tool along with the end mill that's currently in there. So I'm going to take this wrench and lefty-loosey, righty-tighty. So I'll just loosen this. There will be one sort of hard stop in the holder that you'll find, and you just want to get past that. You don't want to do what I just did, which was let the tool drop in there. Usually you want to have one hand holding the tool. Because I'm filming, I did not do that. So I'm going to pull our end mill out of our tool holder very carefully here, if I can find it. Okay, there's our end mill. We're going to put this in a safe place because that's a very nice end mill. I'm going to put our tool holder back in here. We want to clean out the bore so it's got no chips or anything on the inside of it. We can blow it out with air if that would be helpful. This is the half nut with the collet in it right now. We are going to take the collet out. You'll see, I'll take it out and then you can see the inside of it. On the inside of the half nut you can see there's a little lip that's offset to one side. That is the lip that holds the collet in place. So what you'll do is you will insert your tool, your collet, onto that lip and then push it upward. So the collet will then be seated on that lip. So I've just pressed one side of the collet on it, and then I will press the other side up until it snaps, and now it's held in place and it should be flush. Now we're going to set that on here and just get it preliminarily screwed in a little bit. Then we will take our drill, put it into our collet, and then tighten it down. You don't want to tighten your tool down crazy tight because you actually can crack these half nuts, and then you also want to make sure your tool is inserted the full length of the collet so that there's no extra pressure on one half of the collet versus the other. That can also damage your tool holder. This is a brand new tool holder, so I want to be really careful with not damaging it. So I want to load this tool into tool position 10. So I will call up tool 10 on my spindle. So there's not currently a tool loaded into tool 10, so it's currently in our spindle. I will load this tool in and then we'll pick up from there. Because we've already found the top surface of that block, the block we're going to be cutting, and we've already we haven't measured our tool length here, so we're going to go to some position on that top face, use the same technique with the dowel pin to find our 15.88 millimeter height, and then we will measure the tool length. So in handle mode, I'm just going to bring it down to about where it's at. It's somewhere in the middle of this block. I set my dowel pin on here, and now I'm going to raise up the Z until that dowel pin will go under it. So yeah, the dowel pin will go under it there. I'm going to bring it back down just a little bit. Try it again. Yep. Yep. Alright, dowel pin won't go under it. I'm going to switch to a lower increment and go upward. And you'll do that until the dowel pin just slides under. Now that the dowel pin just slides under, we are going to set the tool height. So first we're going to go to offset, and instead of doing work, we'll go to the offset menu. These are the numbers of tools that we're using, and these are the actual lengths of it. So I'm going to go to tool 10. I know the current length that it's at right now is 156.823. So we'll type in 156.823 into here, and then we'll type input. Now that sets that value as 156.823. So that's great. That tells our tool it's that length, but our tool isn't actually that long because we also included that dowel pin in the length. So we're going to type in negative 15.888 or 88. And we are going to add that negative number onto the 156. So plus input, execute, and now it reads 140.9. Let's double check that that number is okay. We're going to go to program. We're going to go back to auto mode, shut our doors here, and we want to go to MDI. Once we're in MDI, we will type in G43H10. This calls up that length compensation value that we just entered. And once I hit cycle start, it should add that value. And now we can see our tool thinks that it's at position 15.88, which is great because that's what we just set with our dowel pin. So that's how you set a tool length. To transfer files to the hybrid, it's pretty simple. We run everything through our Ethernet network here. It's a local network just between this computer, the laser, and the hybrid system here. When you log into this computer, instructions for this can be found in Windows, GX250 hybrid repository, documentation, GX250 documentation, and Andrew's instructions. This is set up FTP over Ethernet. Most of this stuff will say the same. This is only for the computer that you're currently using, so you can ignore this because this computer is already configured for that. When you open FileZilla, this is key to your user account to get connected to it. So we will open FileZilla, open the site manager, enter all of this information into the fields and click OK, and then you should be able to connect to the FANUC controller. If the FANUC controller for whatever reason isn't set up, you can use this information. I have never had to do it, but you may need to depending on what happens with the system. Alright, so once you open up FileZilla, I have mine pinned here, but you can certainly go into Start menu and find it under FileZilla FTP client. Once you open that up, you can go to the top left here, open the site manager, and find your GX250. I put 250 million in mine because I'm hilarious. And then once that's open, you'll see you have two panels here. The one on the left connects to the folders on your computer. The one on the right is are the files that are on the hybrid currently, or on the FANUC controller currently. So if you want to move programs over, you just click and drag your program over to the other screen. It'll do a quick transfer and then tell you that all the transfers have been finished. If you have any parentheses in the name, it won't be transferred properly, so make sure that your names only use numbers, letters, and the occasional underscore. Once you've transferred your files to the FANUC controller, we will go to the file system menu. So first we'll go to the program menu, and then we'll go to folder. Now folder pops up. These are all the local files on the system. We actually want to go to our data server, so if we go to OPRT, this pops up with other options. We will change our device to be the data server. Once we're in the data server, we can see all our files that match the FileZilla client. We will highlight whatever program we want to. Let's run Hot Wall. Then we will press main program. It won't let us set the main program, however, if we aren't in auto or edit. So let's just go to auto mode. Now we're going to go and press main program, use the soft key. You'll notice this is now highlighted with a little @ symbol. Now if we go back to our original program menu, our program hot wall is now loaded into the FANUC controller. From this screen we can edit, we can scroll through and check that we've got all of our information that we need. We can edit the program if we wanted to change our feeds and speeds. You can use parametric programs also, so if you wanted to use different speeds, you could have a variable up here at the top that you just changed. You can do all sorts of cool things. Once you're ready to run, go ahead and hit auto. You're in program mode here. I like to go to check and all. So this reads through line by line. It shows you on the screen what line the machine is reading, and it tells you where the machine is going to move in millimeters. So this is extremely helpful when you're first starting and you've never run your program before, to see that the machine isn't going to crash. So I highly recommend staying on this. Also, you want to keep your rapid speed on low and keep your feed rate close to 0. As you actually run the program and get to cutting or doing additive, you want to have it back at 100. But at least if you've never run it before or you're not sure what it's going to do, keep it at 0. So now I'm ready to run my G-code program. I have my tools set and I have my file in the machine. So I will go to, I just need to load it into our main menu here. It is 002 hole. That's the program we're going to be drilling. So we'll go to main program. Can't set it unless I'm in auto mode or edit. Set the main program. Program, check. We're using tool 9, which stays in here most of the time. It's just a long center drill. And then tool 10, which is our drill that we just put in here. So I'm going to start the program. First I'll set my feed rate down to 0. Start the program, and then slowly raise up my slowly raise up my feed rate until I'm comfortable with how the machine runs. So it's going to bring our tool down, and the program I have has it drilling 2 holes. So first it's drilling a little pilot hole. That'll be where our next drill will seat. Next we will see, we'll make sure this drill moves to the correct location. This is where we want to be careful. If you didn't put that tool height in, the tool would slam down into your workpiece, breaking your tool and probably your holder, and could mess up the spindle alignment. So now that I'm close, I'm going to check my Z height is correct. Yeah, it's at Z 6.64. It's going down another 1.5 millimeters. That seems fine. So it looks like we're okay. So I'm going to let the tool, I'm going to raise up my feed rate, let the tool do its work, and it should be drilling. So this program is going to run for a while, just drilling holes. Once it's done, it'll move the spindle up, and you should be able to take your part out and marvel at your work.